What if leadership wasn't about charisma, but about physics? Not charm or speeches, but motion, force, and logic applied to human systems. In a world where personality often overshadows principle, Elon Musk's empire feels like an equation come to life. Picture this: rockets igniting in slow motion, Teslas gliding through neon streets, engineers sprinting across factory floors. Each frame powered not by chaos, but by an underlying order. Musk's reputation may seem unpredictable, even erratic, yet beneath it lies a framework, a kind of mathematical reasoning for how to bend reality at industrial scale. His approach is not mystical, it's mechanical, a system built on first principles, iteration, and velocity. The same logic that defines a rocket's trajectory also defines his company's momentum. From the outside, it looks impulsive. Inside, it's pure calculation. So, what happens when a mind trained in physics begins treating organizations like dynamic systems? When leadership itself becomes an engineering problem? The result is a man reshaping 5 industries at once, from cars to space to AI. Stay till the end, because this story redefines what the word visionary actually means. The question isn't whether Musk is extraordinary, it's whether his method, grounded in logic, speed, and systemic design, represents a glimpse into the next era of leadership. Is Elon Musk an outlier or a blueprint? Every great leap begins with a question. What are we assuming, and why? That's the essence of first principles thinking, the mental framework Elon Musk uses to dismantle convention and rebuild reality from the ground up. Instead of relying on analogy, this worked before, so it must work again, he breaks problems into their most fundamental truths, then reconstructs solutions as if no precedent existed. When SpaceX began, the aerospace industry treated rockets as disposable, single-use marvels of engineering lost to the ocean after each flight. Musk asked a simple, almost childlike question: why? If airplanes could be reused, why couldn't rockets? By returning to physics, to energy, mass, and material cost, he found that reusability wasn't impossible, it was just never optimized for. The result? Rockets that land themselves, collapsing costs and rewriting the economics of space. The same logic governs Tesla's battery design. Traditional automakers outsourced their cells, scaling through suppliers. Musk started with the chemistry, how energy density, temperature, and materials interact, and rebuilt the entire supply chain to maximize performance at scale. It wasn't business innovation, it was physics applied to manufacturing. This pattern repeats across his empire. When others ask, who's already doing it, he asks, what does the data say is possible? That inversion is his edge. It transforms leadership from imitation into discovery, from copying models to creating new laws of corporate physics. And perhaps that's Musk's quiet rebellion, not against people or systems, but against inherited logic itself. To lead through first principles is to discard history's answers and start again with reality's equations. In Musk's world, speed isn't reckless, it's strategy. Velocity becomes a competitive advantage, the invisible force separating those who adapt from those who decay. He once said, if you're not moving fast enough, your competitor is already building your obsolescence. That idea shapes every decision across Tesla, SpaceX, and beyond. Where traditional corporations worship stability, Musk builds momentum. His teams don't chase perfection, they chase iteration. Each rocket launch, each software update, each production tweak is an experiment. Failure isn't a setback, but data, a necessary input in the feedback loop of innovation. At SpaceX, entire rockets were lost in the pursuit of reusability. Engines exploded, boosters crashed, and prototypes disintegrated on landing pads. Yet each disaster compressed the timeline between what was imagined and what was achieved. That rhythm, test, fail, learn, repeat, created a company that now outpaces entire nations in launch cadence. Tesla follows the same law of motion. Instead of annual model cycles, its cars evolve through over-the-air updates, blurring the line between hardware and software. Speed of learning becomes speed of dominance. Velocity for Musk is not chaos, it's controlled acceleration. It converts uncertainty into momentum, transforming risk into rhythm. And in a world where hesitation costs relevance, that rhythm might be the purest expression of modern leadership. Perpetual motion, powered by purpose. In most companies, engineers build and executives decide. Elon Musk dissolves that divide. He is the engineer CEO, a hybrid mind that treats leadership as a design problem. Instead of managing people, he manages systems, feedback loops, production flows, and information density. His role is less about motivation and more about optimization. Inside Tesla or SpaceX, hierarchy flattens under the weight of logic. Decisions flow not through titles but through competence. Musk expects every conversation to trace back to data, equations, or test results. Meetings without substance vanish. What remains is a culture built on precision, uncomfortable, exacting, but relentlessly effective. He dives into technical minutiae most CEOs avoid: circuit architecture, propulsion physics, supply chain bottlenecks. That depth intimidates and inspires in equal measure. For engineers, it creates a leader who speaks their language. For managers, a standard that borders on impossible. Yet it's this immersion that keeps his companies aligned with reality. Physics doesn't negotiate, and neither does he. The paradox is clear. Musk's authority comes not from command, but from comprehension. By engineering the organization itself, he transforms leadership into an extension of design. In a world obsessed with management theory, he reminds us that control doesn't come from distance, it comes from knowing every bolt in the machine. Every Musk company begins with a question too large for most boardrooms. What problem threatens civilization itself? That's the nucleus of what could be called the mission economy, a model where purpose is not a slogan, but the central operating system. Each venture exists to solve an existential bottleneck. Tesla tackles energy, accelerating humanity's transition away from fossil fuels. SpaceX addresses survival, ensuring life becomes multi-planetary. Neuralink explores evolution, expanding the interface between biology and machine. Even the Boring Company and Starlink fit into the same gravitational field: infrastructure and communication for a planetary civilization. These aren't separate stories, they're connected equations. Viewed together, Musk's companies form an ecosystem, not a portfolio. The revenue from one mission funds the research of another. Tesla's advances in batteries feed SpaceX's power systems. SpaceX's material science feeds Tesla's production lines. Profit becomes propulsion, a means, not an end. It's easy to mistake this ambition for ego, but the pattern reveals a consistent logic. Each company is a node in a single network designed to extend human capability. Musk builds not for quarterly gains, but for continuity, the preservation of civilization through engineering. In the mission economy, success is measured not by market share, but by whether humanity moves forward. Few leaders treat failure as fuel. For Elon Musk, it's not a slogan, it's a process. His philosophy is simple. Failure is an option here. If things are not failing, you're not innovating enough. Behind that statement lies a framework, a loop of testing, breaking, and rebuilding that converts error into progress. The early years of SpaceX captured this mindset with brutal clarity. Falcon 1 failed 3 times in a row. Each crash consumed millions, crushed morale, and drew mockery from experts. But to Musk, every explosion was an equation unfolding in real time, new data revealing what physics had hidden. By the 4th attempt, the lessons had solidified into precision. Falcon 1 reached orbit, and the company's survival ignited a revolution in private spaceflight. Tesla followed a similar arc. Battery fires, production delays, quality crises, all treated as diagnostic signals, not disasters. Instead of retreating, the company increased its rate of iteration, shrinking the gap between experiment and insight. This is the deeper truth. Musk doesn't glorify risk. He systematizes it. Each failure becomes a data point, feeding a continuous loop of refinement. In that loop lies his real advantage. Not fearlessness, but learning velocity. Because in his universe, resilience isn't about enduring chaos. It's about engineering it into progress. Behind every breakthrough, there's a human cost. Musk's empire, for all its innovation, runs on relentless intensity, a pace that stretches people, systems, and sanity. Inside Tesla's gigafactories or SpaceX's launch facilities, the culture mirrors the velocity of the machines: long hours, impossible deadlines, and an expectation that mission outweighs comfort. Critics call it unsustainable, a leadership style that burns through talent as quickly as it creates results. Stories of exhaustion, turnover, and emotional strain paint a stark counterpoint to the triumphs. Yet the paradox remains. This pressure also forges exceptional outcomes. Teams that endure it often produce what others deem impossible. Musk's logic is consistent with his physics mindset: maximum output under maximum constraint. But humans aren't machines. The very intensity that accelerates innovation can erode stability. This raises a question few leaders confront honestly. Can we scale genius without scaling exhaustion? Some argue this is the unavoidable price of pushing boundaries. Others see it as a flaw in Musk's system, proof that optimization without empathy has limits. The truth may lie between. Progress demands friction, but not fracture. And in that balance between ambition and humanity, the next evolution of leadership may yet be defined. The world sees Elon Musk through headlines and memes, a digital persona shaped by chaos, humor, and controversy. Yet behind that noise stands a man immersed in technical precision, a builder more than a broadcaster. The public image may fluctuate by the hour, but the private engineer remains fixed on data, design, and deadlines. Scroll through social media and you'll see provocation, unpredictability, and spectacle. Step inside a SpaceX control room, and the contrast is striking. Quiet focus, methodical systems, disciplined execution. The same person who tweets in chaos runs launch operations with mathematical calm. It's not contradiction, it's compartmentalization. Musk uses communication as he uses engineering, as a tool. The online persona captures attention, while the engineer channels it into momentum. Controversy, whether intentional or incidental, often amplifies visibility for missions that rely on global engagement and capital. Still, the split invites misunderstanding. The caricature of the impulsive billionaire often obscures the reality of a man who spends nights in factories debugging processes. Leadership, for Musk, isn't performance, it's production. And in that tension between public noise and private precision, the modern leader's dilemma emerges. Can you remain authentic while operating at planetary scale? Elon Musk doesn't run companies. He designs an ecosystem. Each venture is a module in a larger architecture, connected through shared technology, capital, and talent. Where most leaders see organizational boundaries, he sees interfaces, places where information and innovation can flow freely. Tesla's battery expertise fuels SpaceX's power systems. Neuralink's advances in robotics inform Tesla's manufacturing automation. Starlink's global internet network supports both Mars communication and Earth-based autonomy. It's not coincidence, it's deliberate integration. Every company is built to reinforce another, turning what would be separate industries into one interdependent system. This structure reflects Musk's core engineering instinct: eliminate redundancy, amplify feedback, and reuse proven components. Just as rockets share engines across models, his enterprises share solutions across missions. The effect compounds. Progress in one field accelerates progress in all. Financially, this creates strategic leverage. Each success funds the next frontier. But the deeper logic is intellectual efficiency. By orchestrating multiple companies like circuits in a single machine, Musk transforms complexity into coherence. It's here his ambition feels architectural, not impulsive, a design for civilization scale scalability. The architecture of ambition isn't about owning more companies. It's about wiring them to work as one. Most leaders think in quarters. Musk thinks in centuries. His time horizon stretches beyond product cycles and market trends, toward the survival and expansion of consciousness itself. It's what he calls civilization-level thinking, a framework that treats the future not as a forecast, but as a design challenge. At Tesla, that vision translates to sustainable energy, ensuring Earth remains habitable. At SpaceX, it extends outward, to Mars and beyond, building redundancy for human life across planets. Neuralink, in turn, addresses evolution, the bridge between biological intelligence and the digital frontier. Each mission serves a single equation: preserve and advance the probability of a future worth living in. When Musk says, "The purpose of life is to make the future exciting and worth living in," it isn't sentiment, it's system logic. Excitement becomes a measurable signal of progress, proof that innovation hasn't stagnated into comfort. This century-scale lens redefines what leadership means. It's not about managing the present, but engineering the trajectory of civilization. And whether one agrees with his methods or not, Musk's worldview leaves a question echoing across boardrooms and laboratories alike. How far ahead are you really thinking? After 2 decades of volatility, invention, and scale, Musk's method distills into a simple blueprint, one built not on charisma, but on cognitive design. At its core lies the physics mindset. Break problems to their fundamentals, question every assumption, and rebuild from the laws of reality, not from the comfort of convention. Then comes clarity, the discipline to communicate vision in equations, not slogans. Musk leads by logic, not personality. His decisions, however chaotic they appear, obey measurable principles: cost, energy, efficiency, and time. In his universe, the variables may change, but the laws remain constant. Next is courage, not the absence of fear, but the commitment to act before proof arrives. He invests, launches, and iterates long before consensus forms. This is leadership as controlled exposure, where risk isn't avoided, but engineered. And finally, iteration, the humility to refine endlessly, knowing no system is ever finished. Together, these traits form a mindset transferable beyond rockets or cars. Think from truth, move with speed, learn through failure, and align effort to mission. Because leadership, at its highest level, isn't about authority. It's about coherence, when thought, principle, and motion all obey the same laws of reality.